Hey, what's going on, guys? Let's do this problem right here. Here this question is asking for the equilibrium temperature of the earth. Here they have provided intensity received by earth, that is 1361 watts per meter square, and also emissivity is provided by 0.9. Since this is a radiation process, we can use this equation, that is q dot is equal to emissivity times surface area times sigma, that is Stephen Boltzmann's constant, and then t power 4. This is what we are trying to find, this t, right? Now let's rearrange this equation, but before we do that, let's see whether we have all the information. We need q dot, it's not provided, right? We have emissivity provided, surface area, we can calculate that one, and sigma is Stephen Boltzmann constant, we know that already. And here we have to find q dot. So here we have intensity provided. From this one we can find q dot because intensity is equivalent to power over area. Power is basically q dot because if you analyze the unit, it's joules per second. That's what power, right? Joules per second. This is equal to power. So instead of writing P, we can write I is equal to q dot over area. Now if you rearrange this one, you will get q dot is equal to I times area, and then I for earth is intensity received by earth is 1361 watts per meter square, and the cross-sectional area of the earth is going to be circle, so we had to use pi r square, and here instead of r square I had to plug radius. Now let's do it in next step. 1361 watts per meter square times 5 times radius of the earth. Radius of the earth is 66378,000 meter, right? This square. And if you calculate this one, you should get 1.74 times 10 to the power of 17 watts, and that's going to be the q dot. Now here we have the q dot. We found out that one right here. Now let's see, and all the other informations are available, but we have to calculate surface area too, because surface area and cross-sectional area is two different things, right? For surface area we have to use different equation, and let's see. Here we have to rearrange this one first. T power 4 is going to be equivalent to q dot over emissivity times surface area sigma. So we have to, in order to find t, we have to take fourth root of this one, fourth root of q dot over emissivity times surface area. For a spherical shape, the surface area is going to be 4 pi r square, right? Earth is a spherical shape, so we can use this one, times sigma. Now let's go ahead and plug the values. So first we are going to have we need only this information. Let's get rid of this part. Okay, so let's continue this one right here. So temperature is going to be equivalent to fourth root of q dot. We found out that one right here, that is 1.74 times 10 to the power of 17 watts over epsilon, that is emissivity, 0.9 times 4 phi times the radius of the earth, that is 6,378,000 meters square, right? And then we have to multiply this by Stephen Boltzmann's constant. That's always going to be the same value, that is 5.67 times 10 to the power of minus 8 watts per meter square Kelvin. And if you calculate this temperature, you should get 286 Kelvin, and if you convert this one into degrees Celsius, that will be 13 degrees Celsius, and that's going to be our final answer. I hope it helps. Thanks for watching.